All right, here we go. So, okay. So 300 is invested at 8% compounded continuously after a period of 3 3/4 years. How much will it result? So there's two formulas we use in this section. One of them is A equals P 1 plus R over N to the NT, and the other is the PERT formula, I call it. I can't remember how much I've said or haven't said. This one here, the PERT one, is when there's continuous compounding. And the other one is otherwise, when it's not continuous. So on this problem, it is continuous. I've just written over the top of it, but this problem does say continuous compounding. Maybe I should erase what I just did there so we can see the problem. So yeah, see how it says compounded continuously. So when it says compounded continuously, I'm going to use the PERT formula. All right, and so $300 is invested. Where does the 300 go? That's the P, huh? The 300 is the P. That's the principal investment. First money you put in the account. What is the R, the interest rate? Yeah, it's an 8%. And what is the time? 3 3/4 years. I would just, make that 3.75, right? 3/4 is 75 cents, 3.75. For the time, like that. We all good there? So, and then just hit the buttons on your calculator, and we'll find the amount. Anybody have it? $404.96? Thank you. Samantha, right? 404.96? Was somebody else getting that? A couple people validate that? Yeah. So that looks like the answer. Good. That makes sense on that one? Questions I can answer? All right, so there's two formulas. We use the PERT formula for continuous compounding. We use the other formula when it's anything other than continuous compounding. And I'll give you both those formulas at the top of exam 3, which we have in 2 weeks. They'll be right at the top, so you don't got to memorize them. Just know how to plug in and use them. There we go. Let me let you try that one. To get $8,000 after 3 years, 9% compounded monthly. Find the principal needed. So first thing to decide is, which formula, which of the two formulas am I going to use? So are we going to use the PERT formula on this one or the other one? Yeah, because it's not continuous. It's monthly, huh? So it's not continuous compounding. It's monthly. So I'm going to use the P 1 plus R over N to the NT. That good? Like that. So that's what we're going to use. So plug in the stuff from there. So they're saying find the principal, huh? So they want us to find the P, don't they? Is that good? So what's the 800 then? Yeah. To get 800, right? So A is the amount you get later. Everybody with me on that? A is the amount you get later. So that's the 800. P is the principal amount, the first amount that you put into the bank account, or the whatever account, right? So you put in the principal, it grows to become a bigger amount later. The R is 0.09. What's the N? Do you remember what the N is? 12. Yeah, N is number, it's 12 in this case, number of compoundings per year. Well, probably goes off the screen. Yeah, number of compoundings per year. So N is 12. So monthly is 12. If they say quarterly, it's 4 times a year. If they say, semi-annually, that's twice a year. I'll just leave that like that. So the R is 0.09. The N is 12, and the T is 3 years. T is number of years, so that's 3. So now, how am I going to solve that for P? I got to divide by that big old parenthesis chunk, don't I? So 1 plus 0.09 over 12. That's just, I'll just make that power 36 there, make it easier to type into my calculator. Boom, like that, right? You just divide both sides by that whole entire parenthesis chunk. Right, so then just here's our calculation. So the principal, the answer should be something lower than 800 that will grow to become 800 after 3 years. So we're looking for a lower answer. 600, 700, something in that neighborhood maybe. Somebody got it? 611.32, that sounds reasonable. Anybody else getting that? Yep, good. That looks like the answer. So it means you need to put 611.32 in the bank. And after 3 years, at 9% per month, it'll become $800. Questions on that? Let's see how that works. Not too bad so far, right? Good? It's going to pick up in trickiness a little bit. All right. Oh, I just bumped it. So to get 2,000 after 1 3/4 years at 3% compounded daily. So is this one compounded continuously? Yeah, it's not continuous, it's daily. So we're not using the PERT formula, we're using the 1 plus R over N to the NT again, right? You only use the PERT formula when it says compounded continuously. And we'll use the PERT formula a bunch in the next section. All right, so try that. Good. Plug everything in there. So, daily. What is N for daily?
365.
Yeah. What about if it's leap year though? We just skip that. Yeah, we just use 365. Yeah. So I just want to let you know. You just always use 365. Yeah. Actually, some financial institutions use 360. I don't really understand why, but that's what they do. Anyway, so to get 2,000, what's the 2,000 then? Is it A or P?
A.
Yeah, it's A. Does everybody see that 2,000's A? Because you want to get 2,000. You want that to be the amount you come up with later, right? A is always the amount later. P is the amount you put in it first, the principal, to grow to become the A later. Right? And then the R is is 3%, so 0.03. The n is 365. And the time, 1.75 years, 1 3/4. Yeah, just make it a decimal, be easier to use. Like that, we good? And then just divide by that whole ugly chunk. I'd encourage you to try this on your calculator. Make sure you can get the right answer, because it is a little challenging, even just to do the calculator well on these. So, what is that piece? Some lower amount than 2,000. Thank you. 1897, 71. Anybody else getting that? Great. So there's the principle. If you have trouble getting that in your calculator, hang out after. Probably just take 15 seconds. I can show you how to, if something's going wrong on the calculator on that. Question?
Is there like a certain number that we don't have to go past when doing the calculator, like entering the, not because I just want to be lazy, but just for practical purposes, like I know with like
number of decimals or?
Yeah, like with,
oh yeah, they're asking near a cent, at least on these.
So that means when you divide by that 1 point whatever, you don't really need to go past a certain number, right?
Oh, I see what you mean. Is what you're doing, are you like getting this decimal on your calculator? And then wanting to round it before you divide?
There's like 9 numbers after decimal.
Right. Well, you did this first, you're saying?
Right.
Right. Okay, let me say 2 words about that. I totally understand your question now. Yeah. So, yeah, because if you type this into your calculator first and get some kind of answer, and then go back and take 2,000, I would use the answer button on your calculator. Do you guys know about the answer button? That way you just get all the accuracy. Because you really don't want to round halfway through a problem. It can throw you off by more than you're thinking. But it's not the end of the world as long as you use a bunch more accuracy. If you're going to round, if you're forced to round halfway through a problem, just make sure you use a lot more decimal places than they want in the end. So if they want 2 places in the end, they want near a cent, then use like 4 or 5 halfway through. But the easier, the quicker and more accurate thing would just be to use the answer button. Yeah. You guys know that? Most calculators now have an answer button. It's really nice. It just brings up the last answer. So just compute this and just go 2,000 divided by answer. And it's quick and you have all the accuracy you need, and that'll do it quick. Or just straight type all this in without ever using an answer button. Either way would be great. Good? Other questions on that? All right, so hang out after about effective rate. All right, so this question is talking to us about effective rate. So before I go into the details of solving this particular problem, let me just give you an idea of what effective rate really is. It's very common in our society. In fact, there's laws on loans. They have to give you the effective rate. It's also called the APR, annual percentage rate, or APY, annual percentage yield, same thing. Those are synonyms. They all mean the same thing. What it means is this. When somebody lists a certain rate, and then they say it's compounded anytime more than once a year, then it's going to actually become a different rate in the end. Not much different, but a little different. So let me give a really simple example. What if somebody says 10% compounded? The way they'll say it is they'll say 10% annual. What does annual mean? Per year. Annum, year, right? 10% annual compounded, let's say semi-annually. What's semi-annually mean? 2 times. Semi's half, right? 2 times, twice a year. Okay. So what does that really mean? Well, did you realize if somebody says, okay, I'm going to give you this loan or there's this investment, either way, 10%, but it's done twice a year, that's not really going to, the effect of that is going to be a little more than 10%. Now, it's not 20. It's not 10 and 10. That's not what they mean. What they mean in the financial world when they say 10% compounded semi-annually, what they mean is they do 5% twice, which again is not exactly 10. I'll show you why. Because the second time you have some buildup, so it's a little more than 10. So, but that, I want to get the big idea in your mind first, and I'll show you how to crank it out. You get that idea? When they say 10%, 10% done twice a year, they don't mean 10 and 10. They mean it'll be a total of 10 in the end. Break it up and do it twice, so that'd be 5 and 5. Or if they say 10% compounded monthly, well then they would take that 10% and they divide by 12, and they break it into 12 little pieces and do that 12 times, which again would come out a little better than 10 in the end. Does that make sense? You get the big idea. So that's first off just what they even mean in the financial world when they talk about a percentage compounded more than once. They don't mean do that same amount every time. They mean break it up into little bits and do it every time. But the effect, the annual yield or rate, really the effect is a little more than the listed percentage. Well, how much more? How do you know? Well, let me just show you by hand. Let's just, on this really, really simple example. If I just say, hey, make an easy number, $500. Is that what you said too?
I said 100.
Oh, 100. All right, I'm going with 500. So $500, right? I'm going to put it in a bank account, and they're telling me they're going to pay 10% twice a year. What would really happen? And this isn't what you're going to have to do. I'm just going to show you. I'm going to show you the quick little formula in a minute. But for now, just longhand, you would just say, well, halfway through the year, they would pay me 5%, right? 5%. So let's just do it by hand. You just multiply by 5%, right? What's that? $25, right? $25. So halfway through the year, they'll give me 5%, right? They're going to do 10%, but in 2 increments, so 5%, 5%. So halfway through the year, they'll throw an extra $25 into my bank account. So now I've got $525. And at the end of the year, they'll give me the other 5%, but now you see that 5% is on a larger amount. That's what makes it come out a little better than 10 in the end. So what does somebody have that number? I can't do that one. 0.05 times 525? 26.25. Thank you. So in the end, add those up, that's 51.25 interest. That's better than 10%, isn't it? Do you see? 10% would have just been $50, right? 500, the original. 10% of that would have just been 50. This is a little better than 10%. In fact, if you want to figure out exactly what it is, you could take the 51.25, divide by the original 500. And it'll be 10 point something. Or the decimal will be here, 0.1025, is that what it is? Then change that to a percentage, 10.25%. So really, 10% done twice a year comes out 10.25%. It's a little better than 10%. That's the real effect. That's what will really happen to your money at the end of the year. Any dollar you put in there at the end of the year will grow by 10.25% in a 10% done twice kind of rate. So that's what they mean. You go on the website. I'm looking at refinancing a house and our house. So anyway, I was looking at rates. Right there on the website. You go to the website, it'll say, whatever the percentage rate, and then it'll say APY or APR, and they're listing that right next to it. There's always a little higher. They're saying this is the real effect of the money. And in fact, there's laws that say they have to not hide that. So that's the real effect of the money, of the type at the end of the year. If you did 10% monthly, if you did it like 12 times, it would come out even a little better. Not much. These aren't huge. They're really small. I don't know. I'm just guessing. It might be 10.28, or I don't know, 10.3. But it's going to be a little better than 10.25. 10.25 was done twice. It'll be a little higher, maybe like that. I don't know. We can figure it out in a minute. But so you get the idea, though. The more frequently you compound, it has a little better effect. All the way up to what's the most frequent compounding? Continuous. Yeah. Continuous. And that would be, I don't know, it might be 10.3. I mean, it's not huge. But it's a little higher than the listed percentage. That's what we're trying to figure out. All right. So with that in mind, this isn't how we're going to do it. This is just me showing you kind of the feeling of it. But let's get to the actual how do you do it. So for effective rate, I'm going to I'm going to give you a different method than the Math Excel here. Because I think my method's a little easier. Just put in $1 for 1 year. To find the effective rate, whatever kind of situation they're listing, to find the real effect, just think about it. Just put in $1 for 1 year. Find out what happens to $1 after 1 year. Then you know what's going to happen to every dollar, right? So put in $1 for 1 year. Then well, take the answer, instead of then, I should say the answer. Take the answer and subtract the original dollar. And if you take out the original dollar, all you have is the growth. That makes sense? We put in $1. What did it become after 1 year? Then take out the original dollar, so you just have the growth. And then change to a percentage. Move the decimal 2 places. So that's the game plan. I'd encourage you to write that in your 3x5 card for the exam in 2 weeks. There's definitely an effective rate question on there. There'll be one question. It'll say, find the effective rate of blah, blah, blah. You know, this is exactly what you need to do. So here, all the same formulas. So in other words, I'm either going to use the PERT if it's continuous, or I'm going to use the other one if it's not. So same formulas. I'm just telling you what you do with the formulas. So this one is compounded quarterly. So that's not the PERT. That's the A equals P1 plus R over N to the NT that we've been using. And here we go. What's the principal? Put in $1. The principal is $1. We're just going to find the effect, we're just going to say, hey, tell me what happens to $1. Then I'll know what's happening to every dollar, and I'll know the real effect of this account. This is my little method, and this is all. I didn't think any deep, amazing thoughts. I just thought, because they have a harder way of doing it, and I just thought, no, you don't need to do that. Just put in $1, find what happens to $1, and then you'll know what's really going on. That's all I'm doing. Okay, so the rate is 9 1/4, so that's what, 9.25%? So 0.0925. Good so far. That's the listed rate. But it's compounded quarterly. Quarterly. What's my N? How many times a year is that? That's 4 times a year, huh? Every quarter, 4 quarters in a basketball game or football game. To the N, T, and T is 1 year. Remember, we're putting in 1 year. $1 for 1 year to find the effect. So everybody see how I put everything in there? Well, we're expecting the answer to be a little higher than 0.0925, right? Because 0.0925 is the listed rate. But because they're doing that 4 times a year, they're breaking it into quarters and doing it 4 times. It's actually going to be a little more than 0.0925. Effective rates are a little higher, always.
And are you only going to use the 1 in place of the time?
Yeah, because 1 year. Because I want to find out what happens, right? These are called annual percentage yield. Notice what happens in 1 year. That's what we're trying to figure out. Yeah, see, they never set a time. They just asked effective rate. But what effective rate means is what will be the effect in 1 year. That's the very mean. That's why they also call it APY, annual 1 year percentage yield, or annual percentage rate. So it's 1 year. So $1 for 1 year. Hit the buttons on the calculator. 1.09 what? 57583.
576.
57583.
Is that 3 decimal places?
Well, careful. That's after the movement. So we got this answer first. You guys good there on the calculator? Then I subtract the original dollar, because that was the original dollar I put in. I just want the growth. So the growth is the 0.0957583. Move the decimal 2 places to make it a percentage. So it's 9 point. And how many they want? 3. 9.576. Yeah. So 9.576%. That's the actual APY or APR or effective yield. Makes sense how we did that? So I just put in $1. I said, hey, $1, what are you going to become in 1 year? The $1 said, I'm going to become $1.0957583. That's what will happen to that $1 in 1 year. I thought, well, if that's what happens to $1, get rid of that dollar. Every dollar is going to grow by 0.09575. Move the decimal 2 places. Every dollar is going to grow by 9.576%. So that's the effect. That's what's really happening. Good on that? Questions I can answer? All right, try that one. Give you a second. Effective rate, 4% compounded continuously. So it's going to really be a little more than 4%, the real effect. which formula are we going to use on this one? Yeah, compounded continuously. This is the PERT one, isn't it? And effective, whenever they say the effective rate, we put in $1 for 1 year. So put in $1 for 1 year. That good? Hit the buttons on your calculator. This formula is actually easier to use than the other one, huh? The PERT one. $1 for 1 year. Somebody got an answer there. It's 1.04. I know that much. 087. 81, like that?
No, 7.
Oh,
No 7. 8107.
8107, like that? Good. Yeah, and then we get rid of the original $, because what that means is the $1 after 1 year has become $1.04, right? So then what was the growth? It was the 0.04, move the decimal 2 places, 4.081. They want 3. Anybody else get that answer? Yeah. So the real effect, if they say 4% compounded continuously, really the effect on your money is every year they're going to increase, or if you're paying a loan, you're going to pay 4.081%. That's really what's happening. That's the real effect. Is that good? Questions I can answer? All right.
Were you in the sun this weekend?
Yeah. Yeah, I'm an example of when it's cloudy outside,
Yeah.
that doesn't mean you don't need sunscreen. It's so
worse.
stupid. I went took my kiddos skiing on Sunday, and it was cloudy up at China Peak. And if somebody give me a multiple choice quiz on a cloudy day, should you still wear sunscreen? I know the answer is yes, but I was just busy with managing the little ones, and I kept looking up, and there was no sun. And then on the way home, you know how you don't feel it till the end of the day? On the way home, about 4 o'clock, I feel the heat on my face, and I'm like, oh, that was dumb. Anyway, yes, I burned my face skiing. All right, let's try this one. So which of the two rates would yield the larger amount? 9% quarterly or 9.5% annually? So, let me help you with this. Do you realize that when they say the annual, that one is done? That is effective. That's already just 1 year. See, annually, it just means once a year. It's only when they compound more than once a year that it's going to make a change. So if they're just doing it once a year, well, then that is the effect. No need to calculate anything. Does that make sense? If they're saying, look, we'll pay you 9.5% and we'll only compound once, compounded annually once, well then that's what they're paying us. 9.5%, boom, into the year. There's no need to, there's no mystery, no change. It's just once a year. It's only when they do more than once, right? If it's more than one time per year that we need to calculate the effect, because then it'll be different than it's listed, right? So if they do 9% quarterly, then that'll be a little more than 9% because they're doing it 4 times. If you just do it once, it is what it is. But if you do it more than once, then we got to do the little formula. So go ahead, do the little formula on that, and basically they want you to find out, is it going to come out higher than 9.5 or lower? Try to figure out which one's actually better. Based on the real effect of the second one. Okay, so it's quarterly. So it's not the PERT formula, right? It's just the R over N to the NT. Put $1 for 1 year. That's what we always do. We try to find the effect on $1. So say, okay, I'll put in $1, and the interest rate is 0.095, because this is really 9.5%, isn't it? So it's 0.095 is the listed rate. Oh, no, it's 9. It's just 9. And I said, what am I doing? It's just 9. The second one, I'm looking back to the first one. The second one is just 0.9, isn't it? In, what's in? In is number of times it's compounded, so quarterly. In is 4. And time, again, is 1 year. Does that make sense there? A lot of flickers today. It's just not plugged in well. All right, so we good to there. So hit the button. Somebody got it's going to be 1.09. 575. 83. Is it 3 something? Yeah, because the 5 seems high. Yeah. So 1.093. 308. Yeah, that's enough to tell. Move the decimal 9.31. So how does that compare to 9.5? It's lower. So the better rate is the 9.5 done once a year. The large we'd click the button on the top one. So it came up. The 9% came up to 9.3, but that's still not better than 9.5. Good on that? Makes sense how to do effective yield. So whenever they ask you a question, which is larger, they're basically saying find the effective rate, because then you know the real effect and you can compare apples with apples on that. But, I'll just write a note for you that says do effective rate for both, right? So for the first one you would need to go P1 plus R over N to the NT. So that'd be $1, the interest rate, what is it? 14.8. So you go 0.14. 0.148. Daily is 365 for 1 year. And then that'd be for the first one. And then for the second one, you would put in $1 for 1 year also, and that'd be 0.15 over monthly. Monthly, so that's 12, huh? 12 to the 12 times 1. And so you would just calculate whatever both those are and see which one's higher. Does that make sense? I just do effective rate for both of them. I just say, all right, 14.8% daily, $1 for 1 year daily, 365 compoundings for N, 0.148 is the interest rate, right? See what that becomes, and then 15% monthly, $1 1 year, at 15% monthly, it's 12 compoundings. And just calculate, find out what they both are. Anybody get those numbers? Anybody get the first one? I wasn't going to do the whole thing, but here we are. We're almost done with it. We don't have to. I can just go ... Whichever one becomes higher is the higher one. Yeah, I better move on. All right, what rate of interest compounded annually is required to double an investment in 30 years? Compounded, okay. So first off, which of the two formulas? Is this the PERT formula or the first formula?
First.
Yeah, because it just says compounded annually. It's not continuous, huh? I only use the PERT formula for continuous compounding. So it's just the first formula. And then you want to double your investment. So what do I do for that?
2P.
Very good. Yeah, the A becomes 2P. This keeps flickering, huh? I wonder why. If I could do something to help here. Anyway, R over N. Does that make sense? The amount, if you want to double, then you want the amount to become 2P. Right? Isn't that good? That's what double means, that the amount becomes twice whatever the principal put in the bank was. Right? 2P, double. And what's the N?
1.
What's that?
1.
Yeah, everybody see that? Right here, annually means once a year. It's compound. N is the number of times compounded per year. So if it's annual instead of quarterly or monthly or daily or something, then that's just once a year. And then what's the T?
30.
30 years. Yeah, 30 years. So there we go. We're trying to find the R, the interest rate, right? They want us to find R there. What's the first step I'm going to do in solving? Yeah. Does everybody see that? It's going to just cancel out that P from both sides, and we'll have 2 is 1 plus R to the 30th, right? R over 1 is just R, right? Everybody good to there? Good so far? Let me stop right here and give a common mistake that I often see students make on this. Instead of putting the 2p over here for the double, because there's usually a double problem on the test, double or triple or something like that. We'll solve a lot of them, so it's probably going to be one of the tests. Anyway, for the double, students will remember often, they'll go, yeah, it's 2, and they'll forget the p. They'll just think double's just 2. And the thing that messes them up about that is then they get to this point and they get stuck because they're like, well, shoot, I got this P over here and N and R, I got 2 letters, and then those kind of freeze up and the problem will stop there, right? So remember, it's 2P, right? Double means double something, right? So if I just said to you double, you go double what, right? A double has to go with something, huh? Double P. Right, and then it's natural to cancel the p's, and the rest of the problem will flow. So remember, it's 2p there. All right, anyway, get to here. Now, what am I going to do? I'm at this point. I'm trying to solve for r. What do I do to solve for r? It's not easy to do. What do I do there? One at a time. No, I'm just kidding. I think we might have done it one other time. I can't remember. I lose track of what we've done and haven't done. Any thoughts?
30th root.
Yeah. 30th root or 1/30th power. Exactly. Yeah, you got to get rid of that 30. Got to get rid of 30. Now, it's not natural log. In a minute, we'll do some natural logs. Let me distinguish those in your mind right now. When do we do natural log? When it's the letter that's in the power. If that was like a T up here instead of a number, then I would have to do natural log to bring the power down. Right? Which you technically could do for this, but it's overkill. If it's just a number up there, just raise it to the 1/30 power, or the 30th root, same effect. Does that make sense? So if you have a number in the power, a big old number up there you want to get rid of, 1 over that power. If you have a letter, which we'll have in a couple minutes, that's when you do natural log on both sides. So I'm going to go 1/30th power to both sides, and that'll cancel that out. Does that make sense, what just happened? So this will be 2 to the 1/30th power is 1 plus r. The 30 power canceled with the 1/30th. And now just subtract 1, huh? So 2 to the 1/30th minus 1. Two to the 1/30th minus 1. Somebody have a calculator?
2.34%.
So 0.0234, is that what you're getting?
Yeah.
Good. And they want 2 decimal places. Well, give me one more.
Well, what I got is 0.02337.
Good job. So you rounded it right. Yeah, so this is what your calculator will tell you. You guys able to get this okay? Right here, when you go 2 to the power of 1/30th. That coming out okay? Make sure you can get that in your calculator. Grab me after if you're having any trouble. Just 10 seconds. I'm sure we can get you going. So 2 to the 1/30th power, take away 1, should be the 0.02337. Yeah, then you got to move the decimal 2 places. And round it because they want 2 places rounded. And there goes the screen yet again. 2.34%. So in other words, that's the interest rate you would need to make what? To make something happen. To make money double in 30 years. Yeah. Money double in 30 years. Ever heard of the rule of 72? If you go the way of business and you do that kind of stuff, it's the financial people always use the rule of 72. You don't have to, it's not required or anything, but it basically says if you take any 2 numbers that multiply to be 72, like 9 times 8, 3 times something, 24. That's kind of a funny one. Or 2 times 36, or Oh yeah, 600, that's a better one, 6 times 12. Anyway, any two numbers that multiply to be 72, they basically, that's for doubling your money. If one of them is the percentage and the other is the time, that'll double your money. Really close. I mean, it's not exact, but it's super close actually. So in other words, if you have a 9% account and you invest for 8 years, it'll pretty much double your money. Or a not 8% account for 9 years. Either way. You know, if you have a 6%, if you find an investment, this is what investment people always look for. That way they know real quick if they're looking to double their money and how long it'll take. If they see an account that'll pay them 12%, they'll right away think, oh, 6 times 12 is 72. So 12% account, 6 years I'm going to double my money. That's really close to accurate. Really close. It even fits with the answer we got, right? 2.34 times 30 years. If you take 2.34 times 30, I bet it's really close to 72. Because any two numbers that multiply to be 72 are really close to what it takes to double money for the interest rate and the time. So, anyway, it's not exact, it's a rule of thumb, but that's Gauss came up with it back in the 1800s. Carl Friedrich Gauss, perhaps the greatest mathematician ever. Anyway, it's used by financial people all the time now. Rule of 72. Let's take a look at that. Okay, so what interest rate compounded quarterly will be an effect of 2%. All right, so they're talking about effect. So whenever they talk about effective rate, what do we do? Yeah, put in $1 for 1 year, right? Put in $1 for 1 year. Which form is this, the PERT formula or the first one? Yeah, it's compounded quarterly. That's n is 4 times a year. So yeah, it's just the first one. P 1 plus r over n to the nt. That good so far? All right, and $1 for 1 year. So I'm going to put in $1 for P. The interest rate, that's what they're asking me for, huh? What interest rate? What listed rate? Huh? N is 4 times a year. 1 year, right? Remember, you put in $1 for 1 year. We always, for effective rate, you're always saying, what is the effect on $1 after 1 year? You with me? Does that make you getting the hang of how we do effective rate? We always say, well, what, if you want to know the effect, just find the effect on $1 for 1 year. And that'll be the effect on every dollar. Okay, so now, here's the real question. What do I put in for A? I got to put something in because I've already got my letter R here. I don't want this to remain A. I need a number there. What number am I going to put in? Do I put in 0.02?
1.02?
Yeah, good. It's 1.02. It's a little tricky because remember, that's the amount that it'll become later. So if you want $1 to grow by 2%, you want that to be the actual effect, then the dollar will become $1.02. Right? Does that make sense? A is the amount. It's not just the growth. It's what you got to keep in your mind. It's the actual original dollar and the amount. Remember, that's why when we go backwards, we have to subtract off that original dollar. Am I losing you? Remember, the A is the amount it becomes later. That's the main thought. I probably said too many confusing things. Just focus on A is the amount the $1 will become later. Well, if we're growing, if the real effect is 2%, then the dollar will become the $1.02. Find R on that. So, yeah. Give it a go. Let me give you a minute. Probably be valuable. Let me let you solve that. Let me take one step of cleanup. This will be 1.02, 1 plus r over 4 to the 4. Right? That 1 in the front, I got rid of that. 1 in the front of the parentheses, because 1 times anything does nothing. So I just got rid of that 1 that was in the front of the parentheses. So you need to solve that now for r. Right? So I'm going to... All right, so basically, first off, you got to get rid of that 4th power, huh? So 1/4 power. Remember, so when you got a big old power up there, you want to get rid of. Do the 1/4 out on the screen. Yeah, 1/4 power to both sides, and that'll cancel that. We good for the first step there? So it's 1.02. Kind of getting scribbly here, trying to squeeze it in. 1.02 to the 1/4 is 1 plus r over 4. Good to there? I'll put parentheses around that if it helps. Subtract the 1 from both sides, so 1.02 to the 1/4 minus 1 is r over 4. And then what do? Multiply the whole side by 4. Boom. So there it is. 4 parentheses 1.02 to the 1/4 minus 1. So that should be our interest rate. Somebody got that? Got it right there. Thank you. 0.019 1726. Thank you. And then move that 2 places. 1.9. How many do they want? 2. So 1.99, huh? 1.99%. Is that okay on that? You guys okay with solving that little thing? So you got a big old power on something, 4th power, 20th power, whatever. Do 1 over that on both sides, huh? Cancels it out and subtract the 1 and multiply by 4. Oh, that went off the screen. Okay, right here, I had r over 4, and I multiplied both sides by 4. Yeah, and it canceled. Good? All right, let's move. Okay, let's do the Tanisha problem. $100, 8% per year, monthly. How long before it's 200? All right, so it's not continuous. Then they're going to ask a part B about continuous. But this part is just monthly, so it's A equals P, 1 plus R over N to the NT. Because it's not continuous compounding, so I'm not going to use the PERT formula. Okay, so $100 is going to become 200, right? Can you tell what's being said up there? Don't worry about this part. We'll do this part. That's part B. So how long for 100 to become 200? Basically is what they're saying. At 8% monthly. So go ahead, see what you can plug in and get to happen on that one. How long for 100 to become 200 at 8% monthly? So where's the 100 go? That's the P, right? And the 200's the A? Is that making sense? The A is the amount it becomes later. The P is the amount now, the principal now. 8% is the 0.08. What is the, what's the N number of compoundings? Monthly is 12. Compounding monthly is 12 times. And the time's what I'm looking for, huh? Because notice what it says, how long, right? How long? Always look for the question, like the who, what, when, where, why, how, those kind of question words, How long? So time, huh? They want me to find time. How long before this happens? So there's our equation. Is that good to there so far? All right, so you want 100 principal to become 200 amount at 8% monthly, so 12 times a year. Find T. Okay, so how do I solve that equation now for T? What's my first step? Yeah, let's get rid of that 100, huh? Get rid of that 100 in the front. So that'll be 2 equals 1 plus 0.08 over 12 to the 12T. Everybody good to there? Now, how am I going to solve that for T? What am I going to do? It's natural log time, isn't it? Because the T, the letter, is in power, right? So you get the hang of recognizing that. That's when you need. That's when you need to use natural log on both sides. Whenever the letter's in power. See the last problem. If I can flash back to the last problem real quick. See the last problem is off the screen. Had a number in the power, a 4, not a letter, huh? Just a number, 4. So I didn't do natural log. I just did 1/4 power. Boom, taken care of, right? But on this one, I've got a letter up there in the power zone, right? I've got 2 equals 1 plus 0.08 over 12 to the 12T power So the only way I'm going to get rid of that is natural. You might say, well, Mr. Can't we just do like the 1/12t power to both sides? Well, that'd be a big mess, because if you did that, then you'd have a 1/12t on this side. It would cancel on the other side, and then what do you do with that? I mean, what's that? So see, that's why we don't do that. We don't just do the 1/, when there's a letter, because then we'd end up with a letter on the other side in some weird old power place. How am I going to solve? That's worse than it was before. Look where the t is now. Right? So that's not a good plan when there's letters in power. Does that make sense? When there's letters in power, we need natural log. It worked great on the last problem when we just had a 4 up there. We just had a number in the power zone. Yeah, just do the 1/4 power. It's gonzo. And we're fine with a 1/4 power. Whoops, I just erased it. 1/4 power on the left side, because we can do that in our calculator. But we don't want like a t in the power zone. We can't do that in our calculator. Everybody see the difference? So, all right, so what I'm going to do is I'm going to do natural log on this side, natural log on that side. And when we do, that's the great quality. The power comes down, huh? So we end up with natural log of 2 is 12t natural log of 1 plus 0.08 over 12. That's the great quality of natural logs. Remember me saying back when we first started logs a couple weeks ago, and I was saying, what are logs? Like, what are they really? And the answer is they're made up, like all of math is. Logs were just made up out of somebody's head one day. But they were made up to help us do things that are real, specifically answering financial questions, one of the most useful places. Financial investment people all the time want to know how long for an investment to do whatever they want it to do. And the only way you're going to be able to figure out the how long question, the time, because time's in the power zone, you got to get that out of the power zone, and what does that is logs. What are logs? The opposites of exponentials. That's what they are. They're the inverse functions of exponentials. So you use them to undo an exponential, to bring the power down. That's what logs really are. That's their place in real life. They help us solve exponential questions by undoing the power. All right, so now we can solve for that t. Just divide. Now that the t is out of power and it's just on the base level, no big deal. Just divide by the 12 and the ln of 1 plus 0.08 over 12 on both sides. Kind of running out of room here. Divide by the 12 and the ln of 1 plus 0.08 over 12. On both sides, boom, 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 boom. That puts t alone. And just hit the buttons on your calculator for this thing. Now it's a little tricky. Make sure, to get all this typed in correctly. It's nice if you have the newer kind of calculators that show it as a fraction. It's easier to enter it. Can you read it all? I kind of squished it in there because the screen is cutting me out some room. Bless you. It's cutting me off a little bit here today, so I had to squish it in. Anybody got a time on that? They want it rounded to 2 decimal places.
How did you do that? So you just divided by everything but the t?
Yeah, exactly. Good question. Once the t is out of power, right? When you do the natural log on both sides, remember the 3 log qualities? Adding becomes multiplying, dividing, subtracting, and powers come down to the front, right? That's the greatest quality, that third quality, that powers come down to the front. So that's what I did. I did ln on both sides, and the power came down. Once that t is out of power, it's just on the base level. Yeah, it's just divide by everything other than the t. You said it well, Carissa. That's exactly it. Just divide by everything other than the t, because it's just on the base level now. It's just all multiplying. It's no big deal once it's out of power. Anybody got a number there for t?
8.69.
Thank you. 8.69 years for $100 to become $200 at 8% compounded monthly. A couple of you get that answer? 8.69? Good. Can you get that? If you're having trouble getting that on your calculator, like I said, grab me after class about a half an hour here, 35 minutes. Just take 10 seconds of your time. I'm sure I can show you how to do that. Questions I can answer? Is it me or is it really noisy out there today?
It's really noisy.
I don't know what's going on. Maybe it's a fire drill and it just didn't go off in here for us. I'm just kidding you.
Oh well.
Okay. So same kind of question. See their very first part there? How many years? So right away you go, oh, what are they going to want from me? How many years? What do they want from me? They want time, don't they? How many years? They want time. So I know I'm going to be solving for time. I know time is in the power zone. I know it's another one of these ln of both sides, huh? Whenever they ask you how long, how many years. So anyway, which formula am I going to use? Is it the PERT?
Say, hurt.
Yeah, continuous. Look at that. Compounded continuously. So it is the PERT. So we're using the PERT formula this time because the compounding is continuous, which is kind of easier in some ways. All right. So give it a go. Oh, it sounds like they all went away out there. Went into some classroom. All right, so 30,000 is going to become 45. So the amount will be 45. The principal is 30. And the rate is 13. Is that okay so far? Does that make sense? So the principal investment is the 30. That's the initial. And the amount it will become later is the 45. And we want to solve for t. So that means, well, what's the first step, actually? We have to get rid of that 30,000, right? So you always have to get the base. Whenever you're going to do the ln, yeah, maybe I should mention that. Well, let me write it up here. When, solving for t, which is in the power zone, step 1, get the base alone, and then ln both sides. Yeah, because that's why I'm dividing by the 30,000, because I've got to get the base alone. What's the base? The base is the e, huh? And the other formula, the base is the whole parenthesis thing. Whatever the base is the thing that has the power on it, right? That power is not on the 30,000; it's on the e. So the base is the e. You guys with me? So the base is the thing that has the power on it. You got to get that base alone first, then ln both sides. So divide by 30,000 is that 1.5. And now the base is alone, ln both sides. I'll bring it up to here. So whoops, gonna run out of room. 1.5 e to the 0.13t. And then we ln. So once you get the base alone, then you ln both sides. And the power dethrones. It's the great quality of logs. It's really what logs do for us. It's why they're in the math curriculum, because they allow us to solve exponentials. They're the inverse of exponential functions. Everybody good to there? That power just comes down. The 0.13t just comes down to the front. Good? What's ln of e? That's just 1. Just ignore it. A lot of flickering, huh? All right, so how do we solve for t now? Now that t's out of power, it's no big deal. Just divide, right? And just all we got is 0.13. The ln e is just 1. That's gone. So just divide by 0.13. T is whatever your calculator tells you that is. 3.12. Anybody else getting that? That good? 3.12 years. For 30,000 to become 45. At whatever it was, 13% continuously compounded. Is that okay? Feel like you can do those? So we've had numbers in the power zone, got like we had a 4, put 1 over 4 on both sides. We've had letters in the power zone, t, get the base alone and take ln on both sides. Right? All right, we're close. Okay. So, number 24, 25, and 26 in 5.7 skip. We're just going to skip them. It's all the inflation stuff. We're going to skip it. I have no way of removing it from your homework officially because I wish Math Excel was a little more flexible that way, but I can't. And once, long story, I can't remove it after people have started working on it. So it doesn't allow me to change the assignment. So don't worry about it'll say your grade's lower, but I won't let that affect your final grade in any way. Don't worry about it. Just skip those last 3, 24, 25, 26. They did them wrong. Their answers, the method they're using is technically incorrect. Seems almost kind of prideful for me to say that, but it seemed wrong to me. It was just today, and then I remembered a year ago going through this, and then I thought, no, it should be this other way, and I did it this other way, and then I was getting different answers than them, and then I went on I just typed into Google inflation calculator, just to check who's right here, and I was right. I was right. They were wrong. Yeah, they did something crazy. I don't know why. They just thought wrong about inflation. So they're doing the wrong thing. I don't want to, but we got plenty of material. Let's just skip it. If you're interested, I like all that stuff. Be glad to help you. Come by office hours. I would enjoy talking economics with you and how you really calculate inflation. I'll show you the way they were thinking wrong about it. We'll go on Google and look at inflation calculators. I think economics is very fun stuff. Very interesting. Maybe you think that's weird. I don't know. But if you're interested, come by. Be glad to work with you, but we're not going to cover it officially. Won't be on the test. Don't worry about it. Finish them, and then we got to do 10-2 as well, which is a big section. Is that right? Yeah, we better get a few of these done. All right. Okay, here we go. So basically, this section is the last section in Chapter 5, and then we're jumping to Chapter 10. We're just covering the things the state requires us to cover for pre-calculus. So exponential growth. You probably did some of this back in intermediate algebra. This is never easy. These are hard. Basically, in this section, we're just going to keep using the PERT formula. The whole section. It's all the PERT formula. Because living things grow or decay at exponential rates, continuously. It's like money being continuously compounded. So whenever you have like bacteria in the petri dish and they're growing, or the population's decaying, or the amount of a substance, radioactive substance is decaying, all those kind of things, it's all PERT. It's all continuous growth or continuous decay. So we will not use the other formula, 1 plus r over n, in this section at all. It's all PERT. Now, they'll write it different. I don't remember exactly how but I think they wrote, if you click on the help button, a0 e to the kt. That's fine with me. I don't care what you use. That formula where I'll say or, that one. I'm just going to use PERT because you're used to it. I think it'll be easier for you. I found students like that better because you're already used to the PERT from the last section. So I'll just keep using the PERT formula. But if you click on the help button, I don't want you to be confused. It's the same thing as, you can call that P, or you can call it A0. You can call the thing up there by the T K or R, whatever. They're all just names. So, all right. So with that in mind, I'm going to use the PERT. Here we go. The size, what does it say here? It says the size of a certain insect population obeys they're just giving me the formula on this one. I don't have to come up with it myself. The other ones we will. Determine the number of insects at time 0. Okay. So we don't even need to use PERT. They're giving it to me. P equals 800 e to the 0.02 t. All right, and part A says time 0. So plug in 0. 0. And what's the answer to that? 800, right? Because e to the 0 is 1. Right? Anything to the 0 power is 1. Right? And this is e to the 0, which is 1. Right? So it's 800 times 1. It's 800. So there's part A. We good so far? Don't even need our calculator, right?
Makes sense.
Anything to the 0 power is 1. Right? All right. Part B. Part B. What is the growth rate Okay, growth rate is just that number right here. They just want you to know it's that number. So it's a 2%. They want you, it's 0.02 and then change to a percentage. So it's 0.02, which is 2%. Is that good so far? And then B is, that was B. C. What is the population after 10 days? So you use the population formula and plug in 10. See how I put in 10 for T? We good? And then just hit the buttons on your calculator. And let me know what you get there. But they want it. I think they just want it rounded to the whole number, if I remember right. They'll tell you when you get onto that part. 977. Couple. Is that what they're saying? Whole numbers. Yeah. Anybody else get 977? Is that right? Good. So 977 of the insects after 10 days. They're growing. Population's growing. And then D, I'm going to have to go to a fresh page. D, when will the population reach 1360 and when will the population double is part E. So, good so far? Can I flash to a new page there? Does everybody get that 977 copied down? Okay, good. All right, on to a new page we go. So part D. So again, the formula is P equals 800 E to the 0.02 T. All right, so when will the population reach 1360? So that means I just plug in 1360 for P, right? And they're saying when. Whenever they say when, what do they want me to solve for? T. So right, when means T. Or how long? When or how long? They want to solve T. So how do I solve for T? Yeah, first remember, get the base alone and ln both sides. So whenever the letter's up in the power zone, when it's T, T's always in the power zone on these formulas, right? It's always get the base alone and then ln both sides. You've got it. Hopefully this will get very, very comfortable for you. It already is. Is that a nice number or an ugly number? 1.7? Very nice. If that comes out an ugly decimal, I usually just leave it as a fraction. But if it's a clean decimal, then great. I'll just use the clean decimal. So we good to there? 1.7 equals that. Now what am I going to do? ln, our friend, natural log. Isn't the ln great? It takes the power out of power. Down it comes. So we get ln 1.7 is 0.02 T. ln E and ln E is 1. And then once the T is out of power, as Carissa said, you just divide by whatever's there. Just divide by the 0.02. What is it? 27? Just 27 straight?
Well, no,
It has to be 27
Oh.
straight, right?
Yeah.
Does it? I don't know
It's
why.
asking for the whole number. It was
Oh, whole number?
26. If it's not, it's 26.53.
26.5, so yeah, you're around
Is
27.
this D? It says rounding nearest 10th of the meter.
Oh, does it? 10th?
Nearest 10th.
Oh,
This is D, right?
it is D. You're correct. You are right. 26.5. Thank you. Is that days? Yeah, days, huh? 26.5 days. 26 and a half days until there are 1360 insects. It's how long till there's that many insects?
Do not round until the final answer.
Yeah, it doesn't want you to round halfway through because that can throw off final answers, you know. That's why I was saying what I said over here about the decimal. If the decimal comes out clean, great. But if it's a decimal that goes on forever, you don't want to, because you're going to have to round that. You don't want to round halfway through. I would just leave the fraction. We'll see some of those in a few minutes or Thursday, if not today. And then there's one more part. Has everybody got that copied down? There's another part. But wait, there's more. Part E. Part E, when will the insect population double?
34 points.
Already got it?
7. How many decimal places?
I don't know, probably 1, I think.
34.7.
So what do we do? What's our first step here? Here's the basic formula they gave me. They're asking how long for it to double. To double. This is part E now. How long to double? What does doubling mean? Well, we know what doubling means, but what am I going to put in for P? Yeah, because remember this number here is the initial amount. Remember? I know it might be confusing because we're used to calling that P, and this is A. They're just using P for population now. Don't let them throw you off by what they call things. Whatever is on the right side is the starting amount, huh? And whatever's on the left side, whatever you call it, is what it becomes later, right? So 800 is how many insects started off, right? This is the start number. 800 insects at the start, right? We can also see that because remember that was the answer we got in part A when we plugged in 0 days. That's the start, 0 days. You just get the 800 because e to the 0 is 1. You just get 800, right? Now over here is the later. So basically they want 1600. That's double 800. Everybody good there? Double the 800, 1600 later. All right, how do we solve? You know it quite well. Divide by the 800. Get the base alone. Our friend, natural log, both sides. Power comes down. ln2 is 0.02t ln e, which is just 1. Last step. Divide by the 0.02. Divide. I'm running out of room here. By the 0.02 on both sides. So the t equals ln2 over 0.02. Somebody got that?
34.7.
Well, I'm running out of room, huh? 34.7. 34.7 days until the population for the insects doubles. Good on all that? Making sense? Questions I can answer? Okay, let's keep. Right, so a colony of mosquitoes obeys the law of uninhibited growth. What do they mean? When they say obeys the law of uninhibited growth, they mean PERT. Exponential growth, right? You know how they talk about populations growing exponentially and stuff, and that's true. Animal populations will grow exponentially if they're uninhibited. What does that mean? They have all the food they need. They have all the space they need to spread out, not fight each other for space, and they've got no predators, right? So if you do all those things, they will grow exponentially. You probably read some of you all about the stories like where they introduced, rabbits to some populations that they had never been before, and they had no natural predators, and they took over the island, right? Wasn't it Australia or one of those places? Somebody brought rabbits from, I don't remember, that you can type into Google probably, animals taking over exponential growth of animal population. Anyway, there's some stories from 1800s or early in the 1900s where they took like rabbits, I think it was rabbits, to somebody grabbed them in one place and on a ship and took them back to an island or something where they had never been before, and there was no natural predators there. There were no hawks or there were no wolves or whatever to kill them, and so the rabbits just, they ate everything and they populated, and they just grew and grew and grew to where they were just wiping out the island. I mean, literally, they were coming like you heard a swarm of locusts. It was a swarm of rabbits. They were just going over the farmers' land, and they were just mowing it, and the farmers had to go out there and kill them by the thousands, right? And they had to bring in some predators, I think, to take care of things. Anyway, yeah, so populations will grow exponentially. So whenever they say that, obeys the law of uninhibited growth, they mean PERT. PERT is just like money will grow exponentially, right? If you just leave it in the account. Einstein said that was the seventh wonder of the world. exponential growth of money, right? And so will the critter populations if there's no predators or lack of food or lack of space. All right, so that's whenever they say that, they want you to use per. 1,000 mosquitoes initially. Where's that going to go? That's my P, right? Everybody good with that? Initially means it's the principal. It's the money put in the bank at first or the number of mosquitoes starting off. And there's 1,200 after 1 day. Where's that go? Yeah. That means the amount of mosquitoes is 1,200 after time 1 day. Everybody see that? Does that make sense? So there's 1,000 initially and 1,200 after 1 day. Okay, so what am I supposed to do with that? Well, let me help you now. Basically, the rest of these questions, the less, 8 questions here, we're always going to use the PERT formula, and we're always going to do it in a 2-phase. Let me give you 2 phases to help out, make it a little easier. Phase 1 is where you find R. Phase 1 is all about finding R. You see, that's where we are right now. If I divide by the 1,000, this will be 1.2 equals e to the r. R times 1 is just r, right? We get to there so far? And how can I, phase 1, we're trying to find r. And then after we do that, I'll show you phase 2. But how do I finish finding r now? Ln, here we go again, right? It's up in the power zone. When there's something in the power zone, Ln both sides, yeah. So Ln both sides, and the power is dethroned, it's out of power. And so then we have Ln of 1.2 is R Ln of E. And Ln of E is just 1. So that means Ln of 1.2 is R, huh? R is just Ln of 1.2. That's the end of phase 1. Now phase 2 is you finish. So you start with the PERT formula yet again. But now you can plug in your R that you found from phase 1. This making sense? Am I going too quick?
How many decimal places are we doing this?
Well, yeah, here's where we're going to just leave it Ln of 1.2. Yeah, we don't want the decimal.
Oh.
They say this thing about not rounding until the final answer. So that's what they mean. Just leave it Ln of 1.2. Yeah, good question. Just leave it that way. So this will be Ln of 1.2, and then there's the T. Everybody see what I'm doing there? I just put in the R there that I found from phase 1. So this is how all these last 8 problems are going to be some variation of exactly this. They're all going to be the PERT formula because they're all going to be exponential growth. And, the last 2 or 3 are a different formula, but most of them are the PERT formula. And phase 1 is always about finding the R, or you could call it K, whatever that we'll call it. Then you start over with the same PERT formula in phase 2, plug in your R, and now answer their final question. But actually, let me give you a trick to make this a little bit easier. E and Ln cancel, remember? So this, and that 1.2 will drop down to the base, like that.
Why does it drop to the base?
Yeah, I can explain that
Oh, okay.
on another sheet if you want. Oh, and I forgot the P's 1,000, isn't it? Yeah, this P should have been 1,000 all along, huh? Right, the initial amount of mosquitoes. Oops, I'm running out of room here. 1.2 to the T. Yeah, I can explain that maybe on a separate sheet, why that's the case. But for now, let me just say it is. E, when you have E to a power of natural log, those are opposites. Remember, natural log is the base E. Remember? So those cancel, the 1.2 becomes the base, but the T still stays in power. That's the mistake a lot of people make with this little technique. In other words, it's not like this. This T's not down here. Everybody see that? The T remains in power. Why? Why did the T remain in power, but the 1.2 dropped down? Because the 1.2 was plugged into the natural log function. He was in the toaster, right? The T was not. The T was like, I'm not part of that Ln thing. I'm just sitting next to it. right? That's why I put the parentheses, just to emphasize, you don't have to, but I was just emphasizing that the t is not in there, right? It's not in the toaster. It's not in the natural log function. So when the e cancels the natural log function, what was in the toaster falls out, but not the t. The t was never in there. He was always in the power all by his own self, right? But what was in the toaster falls down to the base, 1.2 to the t. That'll be easier for you to use with the calculator and the calculations, is to do that little trick. I'm not sure whether they show it or not, but it'll make things easier for you. Now let's answer the final question. What is the final question? Oh, there's two final questions, huh? Yeah, 3 days. So how many of these things, what are the mosquitoes? After 3 days. So what do we do? Just plug in 3 for t. 3 days. Plug in 3. So it's A equals 1,000, 1.2 to the 3. 3 days. Does that make sense? Just hit the buttons on your calculator. 1,000 times 1.2 to the third. Anybody got that? Equals 1728. All right, 1728 mosquitoes after 3 days. Does that make sense how that worked? Because there's actually a third question we want to answer. Is everybody good to that one? Everybody see how that works? So we're using the PERT formula on all these, right? The initial amount of mosquitoes is 1,000. So we do phase 1. So you write the PERT formula. You do phase 1 to find R. Then you start over with the PERT formula, put in the R, and the E and the natural log cancel, and what was inside the natural log drops down to the base. If you want to see that, come up after class. I'll be glad to do a little proof for you that they cancel and this actually drops down to the base. T stays in the power. Remember that. He doesn't drop down because he was never in the ln. And then just plug it in 3 days. Hit the buttons. We've got it. Now, if you got that copy down, let's do the last part of this question. Then I'd like to do one more if we can. So we have, what do we have? A equals 1,000, what was it? 1.2 to the t, right? So once you have that formula, just keep using it for all the rest of the questions. Does that make sense? Once you've got that phase 2 formula, you just keep using that thing. What's their last question? How long till 60,000 mosquitoes? Yikes, 60,000 mosquitoes. They always bite my poor wife. I'm always fine for some reason. I don't know why. It's the hair. The hair helps, I think. All right, 60,000 mosquitoes. So you just pop in the 60,000 for A, right? Does that make sense? How long, what do they want from me? Time. Whenever they say how long, right? They want time. So I've got to solve that little equation. This is the last part of this question. Solve that little thing for time. How do you solve for time there? Yeah, we don't get the base alone. L in both sides, right? Divide by 1,000. This will be like 60. 1.2 to the t. Bring it up here. 60 is 1.2 to the t. And then L in both sides. The power comes down. Ln of 60 is t. Ln of 1.2. Good to there. Are we happy about that? Last step. Divide by the Ln 1.2. Boom. T equals 22.5. Thank you. Days. That'd be days, huh? 22.5 days. We're going up to 60,000 mosquitoes. So this is how biologists can track populations. But this is a simple formula assuming there's no predators and plenty of food and plenty of space. And there's more complex formulas they use with more realistic situations. Is that good? Does that make sense on that? I think it'd be good to at least start one more, just to get that rhythm, because these are kind of the same every time. Once you get the hang of it, I think it feels a lot better. One more time, that way it'll be in a little bit deeper memory bank. It's not due Thursday, but so that when we pick it up Thursday, it's a little fresher for you. So, all right, so same kind of thing. Population, blah, 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 exponential law. Assuming there's plenty of food for the people in Southern California, or southern city. I was just assuming LA. Southern of some state. Plenty of food for them and no predators and lots of space. Not in Southern California. They'll grow exponentially. Or if the weather is just really great. The population doubled in size over 30 months. All right, what formula are we going to use? PERT for all these. PERT. It's like compounding money continuously. All right. Phase 1, what do you find in phase 1? Find R. Everybody getting the hang of this? We always have 2 phases. Phase 1 is always about getting your hands on R. So see if you can do it. That'll really help you, and it'll be fresh in your mind for Thursday when we pick this up again. Because I don't have forever on Thursday. I got to do half an hour to be done because I got to start parabolas. It's a long time. U-shapes. And we pick up chapter 10 on Thursday with the U-shapes, parabolas, and those are tricky. They can go up and down and right. We're going to move them up, down, right, left. We're going to find the focal points. We're going to slide them all around and stretch them, and we're going to do all kinds of fancy things with parabolas on Thursday. All right, so I won't have a lot of time to do any more of this. Just a little bit of time. So find R. Find R. What's it saying? 30 months, double. 30 months, double. So what's the A? Oh, current population was 70. So the P is 70, right? That's the current, right? The P is now, right? The current population is 70. Population of such a city. If the population doubled in size over 30 months, yeah, let me give you 2 ways to do it. You could do that, or that might seem weird. You could just say, look, doubling means the amount is 2P. I think that's the easiest way to handle doubling. Right? The amount is 2P. Remember, we did one of those a few minutes ago, right? If something doubles, people, mosquitoes, whatever, money, the amount is 2 times the principal amount. And then divide by the P on both sides.
But 70 is not the principal amount, is it?
Don't worry about it. It depends on what your perspective is, honestly. In other words, I don't know if they're saying it became 70 or it started at 70. Yeah, let me just leave it at that for now. You don't even need to use the 70. If they say double, amount is 2P. Everybody with me on that? Again, don't make the mistake that I've seen so many times. People read double. I mean, I see this a lot. That's why I'm really highlighting it. And they'll just go 2. They won't remember the P. And then they'll be stuck because they won't know how to get rid of the P. Right? It's 2P. Right? Double means double something. There's no such thing as a doubling without an object to that phrase. Double what? Double P. Right? So we drop that out. Time, 30 months. Let me put in the 30 months. We good to there? Is that good? How do we solve for R now? L in both sides. When you got the letter in the power zone, L in both sides. So I've got Ln of 2 is Ln of E to the R times 30. The R times 30 drops down. Ln of E is just 1. Divide by the 30. Because we're trying to solve for R. Divide by the 30. So R is Ln 2 over 30. So that's phase 1. We got our hands on R. Everybody good there? Everybody see how I handled that? I just did double. Amount is 2P in 30 months. Plug in T30 and amount 2P. Solve for R. There's R.
We leave it like that, right?
Yeah, I'm going to just leave it like that. I'm going to leave it like that. Now, if you're okay with that, I'm going to go to phase 2, and I'll wrap up here. So everybody got that copy down? R is Ln 2 over 30. Everybody got that? Now, so we got R is Ln 2 over 30. Go back. This is phase 2 now. Remember, phase 1 is get your hands on R. Phase 2 is go back to the PERT formula. And this time, now you know R, which is what? Ln 2 over 30 T. All right? Everybody good to there? Now, here's the part I want to make clear to you. E and Ln cancel, remember? And the 2 drops down to the base. I can prove that to you if you want after class. What does that leave? T over 30 in the power zone. Everybody see that? Right? Because the 30 And the t, they were not plugged into the ln function. They're just powers on their own. And 30 is the denominator, so it's t over 30, right? So we get to there, and now here comes their question. The current population is 70. So that's the p. If you call it current, it's now. It's like a principal investment. 70,000 now. What's it going to be in 4 years? So 70,000 now. What's plug in T is 4? Not 4, huh? Why not? Why am I messing up? 4 years times 12, 48 months. And remember, we're in months. Why? Because we used 30 in phase 1. In phase 1, we used 30 for our time, and that was months. So at that point, we're sealed in to doing months. We could have done it all in years from the beginning, converted 30 months to whatever that is, but we didn't. So we're in months now. So when they ask you a question later in years, you got to change that to months. So there it is. Hit the buttons on your calculator, and that will be the answer to that question. Somebody have it? What's population? What was the first part, Samantha? 233, 684? Growing like Southern California.
I got 212.
Uh-oh, 212? Maybe hit a wrong button. Is it good reason on the test? Run these calculator things twice. So easy to hit a wrong button. 212 what?
200.
212, a couple of you got that? Sounds like 212, 200. Yeah, easy to hit a wrong button. Run them twice on the test. That's what I always did, literally. I'd run my numbers twice. Make sure I get the same answer twice in a row. All right, guys, well, we're out of time. This is not due